Hello math students, Dr. John, your physics and math professor, coming to you with another trig identity. This one looks sort of convoluted. Here we have 2 cosecant squared theta. Cosecant is the reciprocal of sine, 1 over sine. And then we have these two things. Now these two things look sort of familiar to us. Remember, here's the 4 principles we're going to try to use for these. Difference of squares, Pythagoras, double angle, and trig definitions. We'll have trig definitions. No double angle here. Might be Pythagoras. There's definitely a difference of squares. Looks like a difference of squares. Here's 1 plus cos, here's 1 minus cos, but they're not in the right format. Let's try something here. So let's take this thing here, the right-hand side, see if we can create the right-hand side for that. So we're going to work in this direction here. Let's take this here, each of these terms, and create the same denominator for them. So for this first term here, it would be 1 minus cos theta all over 1 plus cos theta. I'll just extend this here, times 1 minus cos theta. So what we started off with here is just 1 over 1 plus, and I multiplied it by this part in the square brackets. A little messy here. The part in the square brackets, I multiplied top and the bottom by. So that's going to create, on the bottom, it's going to create 1 minus cos squared theta. So that's going to be a very nice denominator for us. It's going to be helpful for us. And the top, it's going to be 1 minus cos theta. Let me write that over here. So the top will be 1 minus cos theta, and the bottom will be 1 minus cos squared. If you remember your Pythagoras, sine squared plus cos squared is equal to 1. So if we just move this to this side, we're going to get sine squared is equal to 1 minus cos squared. 1 minus cos squared. So all of this here is sine squared. We did that on this first term here. That's just for this term. I'm going to do the second term in pink. So hopefully you can see what I did here, the second term. It's going to be very similar. We're going to have this in the denominator. I'm going to erase what I did here. I want to create the same denominator so that we can add these up if we need to. So we're going to start off with 1 minus cos theta and a 1 on the top. So I want to put brackets around there and extend it because I want to multiply this 1 by 1 plus cos theta and this by 1 plus cos theta. Notice we multiplied by 1 minus cos theta here, and here we'll do 1 plus. So we get the same denominator for both of them because we're going to need to get rid of that denominator. So this is going to be 1 minus cos squared theta. We just did that. That's the same as sine theta. So I'm going to go over here. Sine squared theta, I mean. That's the denominator. The top, we don't need this extra 1. It's going to be 1 plus cos theta. 1 plus cos theta. Remember we had a plus sign between them. Now we can erase this. We have the blue piece and the pink piece. There should be a bracket in here. Make sure we don't forget, although the plus sign will apply to both of them, so the bracket isn't needed that much. We have a common denominator, sine squared theta. Here it's 1 plus 1, which is 2. And then these terms over here will cancel each other. Can you see that? It's the same terms, only negative. So this is all that we're left with here. 2 over sine squared theta. We don't need this long extension here. I'm just going to put this in the center. What is sine squared theta in the denominator? It's cosecant squared theta. You just flip it over there, and that's what we have here. We have now proved that identity. If that helped, like this video, subscribe. See you in the next one. Bye-bye.